I was with the British Antarctic Survey for 5 years. While I was at BAS, I started to develop very strong opinions on how science data management should be developed. Science has such limited resources that we really need to be working together and focusing on acquiring data that everyone can use. It became fairly apparent to me that no one else was going to put their hand up to do this, and if I had strong opinions, I was the one who was going to have to work towards making that work. And then at about that stage, the opportunity came up to come down and work for CSIRO around the build of the new vessel. So Investigator is Australia's only blue water research vessel, and we have to use this resource really well. We're trying to build up as good a bathymetric map of the Australian marine environment as we can, and that then feeds into a whole variety of science.
What we can see here is a large canyon and a couple of large landslides that are big enough to have generated a tsunami. Probably somewhere between 50 and 100 could have generated something around 5 to 10 metres, which is the size of the tsunamis that came through Indonesia. The big question for us is how many, how big and how often.
It's one of the next big challenges that faces the scientific community entirely is opening access to data and getting disparate types of data talking to each other. Here's some of the bioacoustics data that we've acquired today. We've taken it as we're coming up the continental shelf up onto Tasmania, so this red line down here is the seafloor. The blues and the greens and the reds basically tell us how dense that bioacoustic mass is in the water column. Imagine a world in which, for example, some natural disaster happens and you can link flow rates from rivers to the state emergency services to known bathymetry of an area. Suddenly you're empowered to understand how many sandbags a particular town needs and where. That is the future of data.